All right, let's get started. So hello, everyone. Welcome. I'm going to talk a little bit about analytics, a crucial part of free-to-play gaming, as you're no doubt aware. So to get us in the right mindset, I want you to kind of follow with me on a little bit of a thought experiment here. So think about one of the games that you've released, that you've developed, you've been involved with. And I want you to pull that game into your mind and just think through everything about that game design. Think about the characters, the levels. Think about overall progression through the game. And I want you to think about two things. First of all, what is the favorite thing about your game to your players, like the number one thing? And then second of all, why do people stop playing your game? And so then, assuming that you have those answers in your mind, then think about, OK, why is that? So why is that favorite thing in your game the favorite thing? Is it because it's an item that has certain powers? Is it because it's red? Is it because it's cheap? Is it some combination of all of those things? And the same thing when you're thinking about why did people stop playing your game? Is it because maybe a level was too hard, which is common, or maybe it was too boring, or maybe some combination thereof? And so when you're thinking about these answers, don't feel bad if you're stumped. A lot of people are. But the reason why I always start and say, OK, think through these things is just to impress upon you that some of the most successful gaming companies out there, they absolutely know the answers to these questions. They have a very fine-grained understanding. Like if you look at the most successful, the Rovios, the Supercells, the Grees, Gung Ho, they all have very fine-grained understanding of their players. They understand level by level, item by item, what makes players tick, and how to keep their players engaged and passionate about their game. So what I'm going to do is walk you through a couple different things today. First off, I just want to spend 10, 15 minutes, talk a little bit about analytics, at least in theory. For some of you that have been doing analytics for a while, this is probably old hat, but at least a level set, so we're all kind of coming along together. And then I want to walk through some specifics about AWS services and technology from the back-end perspective. And I'll highlight what other game companies are doing on AWS in order to get these kinds of insights out of their games. Finally, at the last part, then, I'm going to actually show you a bit more about how mobile analytics integrates with our back-end offerings. And finally, I'm actually going to show you Gree, their actual complete analytics offering and their architecture that's actually based on AWS. At reInvent this past November, they actually came and spent an hour long, and they went through very in-depth detail, talked about their entire end-to-end analytics platform. It's really fascinating stuff, and it's one of the best case studies that we actually have, so I'm going to walk you through some of that. But to start with, this is a report that Gartner released last year at some point, and it basically just underscores the importance of understanding your players, because it basically projects that over the next few years, paid app purchases are essentially going to level out, and in-app purchases are going to continue to be the dominant form of revenue for your game, whether or not it be in-app purchases or ad revenue. And Gartner's not the only one saying that. Anytime you have a crystal ball slide, you do your best to look into the future. But Gartner's not the only one saying this. There's a lot of Newzoo, and other people are also seeing the same thing. And it's definitely a trend that is continuing to progress. So it just underscores how important it is to get that in-depth understanding of players. And it's not just in the US, but this is happening worldwide. This is some data from Newzoo that just shows overall trends. Mobile continues to be the engine of growth. Console growth, if you look at the US, for example, aggregate game growth is kind of slowing down a few % a year, but mobile continues to be the bright spot, 15% a year. And you've got some places, actually, interestingly, if you look down at the Middle East, where their actual handheld, their console growth is declining while mobile continues to then increase at a clip. And in China, the last one I'll highlight, which isn't actually shown here, is that in 2013 and in 2014 similarly, but in 2013, mobile games accounted for more than 50% of Chinese mobile use. And it was basically dubbed the year of the mobile game. And it's a continuing trend that's going on in China and throughout Southeast Asia. So how do you capitalize on this? Well, I think Supercell, the CEO, said it best when he said, well, it's impossible to actually predict success. Everybody would love to know how successful their game is, but you can only really find out actually after you've launched it. So you can spend months and months tuning your game and trying to create the best experience. If you saw Mike Hines' talk just before this, which was a fascinating talk about how he made a game no fun, you can iterate on that forever and just try to create just the best game you can, and you can still launch and it can still be either a great or a poor game. Until you really get it out there and get real player feedback, you don't really know how your game is going to do. And so the clear point here is that you really need to instrument the key parts of your game so that you can measure that feedback. And I'll give you some concrete examples. So what are you trying to do? Well, what you're trying to do is you're trying to say, okay, well, do my players actually have an emotional attachment to my game? Are they enjoying it? Are they engaged? Are they really enjoying all the new content I'm producing? Or are they getting a little bit bored? Or are they getting stuck? Or worst case scenario, giving up and abandoning my game? But that's really basically impossible, as Mike mentioned previously, to measure that. You can't just measure an emotional state, at least not yet. We don't have those little hats that go on and plug into your Cortex. I'm sure they're coming soon, right after the VR stuff. But in the meantime, we have to use proxies. We have to use other things that we can measure out of the game. So here are a few examples, and I'll highlight the good and bad of these. Very common to measure stuff like hours played, number of sessions, overall progression. And then, of course, you can measure stuff like friend invites, friend referrals, the amount of money they've spent, and then any response to their mobile push notifications. Like if you send out a mobile push, do they then come back into game, and correlating that between it so you can decide whether or not your marketing is working. There's a real challenge, too, at the same time with measuring some of these, and this is where the devil gets a bit into the details, and that is if you just measure money spent a week, that doesn't necessarily tell you that those people are happily spending money. You could have a segment of your users that are basically like, okay, I'm stuck, fine, I'll spend $1. They spend $1, and then they're like, I'm out of here. This game sucks, basically. So it's tough for any one of these to actually draw any definitive conclusions. So that's why it becomes very important when you're recording these data and collecting these metrics, and I'll give you some more concrete examples, to be able to correlate multiple sources of data together. You want to find out whether or not they're spending money because they're stuck, or whether or not they're spending money because they're happy and they're an engaged user and they're just trying to increase their happiness with your game. And the same goes, the last thing I'll mention here, same thing goes for friend invites. If, in your game, if you incentivize Facebook invites, like, hey, invite 5 friends and you get 10 points, you really can't tell anything from that data then. Don't go look at your Facebook and say, wow, we have, hundreds and hundreds of people referring. No, you've corrupted your own data. Because you've incentivized it, your data is no longer good. You can't really tell anything from measuring that anymore. All right, so what is our strategy then? Phase 1, collect data. Phase 2, analyze. Phase 3, profit. Obviously, there's a little more to it than that. I apologize to the gnomes. But in a nutshell, that is actually all we're trying to do, right? The key here is actually making sure that we're collecting the right data, that we're actually approaching the analysis correctly, and then we're making tweaks to the game, that they're based on the data we're collecting, and we're making the right tweaks to the game. Just want to mention a few more things just overall about monetization. Again, this is probably old news for you guys, but in the free-to-play model, typically the number that you use is about 5% of your player base is going to monetize. So 95% of your player base is not going to spend anything on your game. Only 5% is going to spend any money, and actually less than 1% typically spends any significant amount of money. So you have a very minute fraction of your user population that's actually going to support your entire game's economy. And actually, VentureBeat just ran an article, I think, last week where they're basically saying that their latest statistics say that 0.15% actually of players accounted for more than 50% of the revenue for the games that they study. So it's a sliver of your actual player population. So in order to be successful in this space, you really need to be able to segment your users and hone in on them and identify the people that are both spending and most likely to spend money on your game. So how do we do that? Well, let's look at one example of something we could measure. So this is hypothetical data, but it looks very much like data you would get actually from a game. And what this shows is this plots on the x-axis, it's our hypothetical levels, level 1, 2, 3, 4, 5, et cetera. And then on the y-axis is the number of times it took us to go, get past that level, complete that level. So we pull this data out of our game. We're recording this via analytics, and I'll get the specifics of that in a little bit. We're collecting this data, And it looks like a pretty expected trend line, except something's happening around level 7. All of a sudden, there's a pretty big bump up where it's taking people 2 or 3 times as long to actually complete that level. So what's going on there? Well, from this data, you can't really derive any conclusions. Like, this could be completely expected. Level 7, maybe it's a boss level. Maybe you designed it that way. Maybe they have to, learn a new skill. Maybe they need to learn how to double jump. Maybe they need to unlock a new item. Maybe there's some kind of new mechanic they have to learn that takes a little bit of learning, but then once they get the hang of it, then they can use that for level 8 too, and it goes back down, and then now they're at kind of a new plateau of fun. So from any one data series, it's really hard to derive any meaningful conclusion. So how can we make this better? Well, the key is multivariate analysis, or multiple variables. There's a lot of fancy terms for it, but it's basically just taking multiple data sets and correlating them together. So what we've done here then is we've collected the number of people where a given level is actually the last level they played. And then we've overlaid that with the number of tries it's taken. So meaning that, okay, when we look at level 7, not only does it take people a lot of tries, but actually the blue bar says there's a lot of people that just give up. Like, that's the last level they even try in your game, and then they abandon your game. So this then, by being able to correlate these multiple sources together, we can drive a conclusion that says, okay, this is actually something we should look at. This is more than just a game tuning. And we need to either make that a more fun level or make it a little bit easier, somehow to make it more accessible so that we don't have so many people abandoning the game. There's a couple of landmines here, though, that I'll point out in a second. But before I get to that, I want to just point out the level 4 aspect here, too. Now we're seeing something else here. Like, the idea being that, okay, something else is causing abandonment on level 4, though. It's not difficulty. We already actually, plotted difficulty first, and it's not difficulty. But in this case, something else about that level. So maybe, again, it's something about the items that people are using or their activities, et cetera. So this then gets you in this cycle where you have to keep digging, asking repeated questions, bring in another data set, then correlate it together. And again, I'll walk you through the specifics of that throughout this hour. The landmine here, though, that I want to highlight is, I kind of set you up and said, okay, this is the percent of highest level that they achieved. How do we define that? Like, how are we actually defining that they left the game forever? Are we using 1 day, 7-day, 30-day attrition? Right? Because a person could just stop playing for 2 weeks and then come back 2 weeks later. I know that the explosion is much more fun. I need more theme music behind me. But they could come back 2 weeks later, and if we're using too small of a time window then we could get a false positive and say, oh, well, this is too hard, and everybody's quitting, when in reality, they were just leaving the game and coming back in for other reasons. So it's really important when you're doing this analysis, either via our tools or other tools that are available, that you're actually going through and making these adjustments to your data series and kind of running these repeated analysis. And if you did this and said, okay, I'm going to use the 30-day abandonment, then maybe that would be accurate, but maybe you have a lot of people that quit your game at 30 days for other reasons. They get bored of your game, et cetera. So there's a lot of art here of being able to tweak these actual parameters when you're putting them together, and we'll talk about that a little bit more as well. So just to drive it home, this is not completely funny data. This is actually an example from Wooga for their game Bubble Island. They talked about this a little while back. But this was just using DAU. Now, they weren't actually able to make any changes based on DAU, but that's what this graph shows as DAU. And they noticed that after, first little bit that their DAU was starting to decline. So they were collecting data, and they said, well, what's actually happening here? And when they dug into that second layer of data, similar to what I was showing you, what they actually found is that after a little bit of playing the game, that either all the levels were played and people were just out of content, or the layers were too difficult and they just kind of gave up. Again, the takeaway here is you can't derive that just from DAU. DAU just gives you a very broad, here's the number of people playing your game, but it doesn't tell you why, it doesn't tell you how, it doesn't give you any segmentation in terms of how long they've been playing. It just is a very big number, right? It's like the population of the United States. Like, that's great. Like, it tells us a little bit of data, but not that much. So what they did then is they went back and they tweaked their game design. And then after doing that, they introduced this level of the week. They said, okay, each week then we're going to introduce a new level, keep the content fresh. And then that saw a corresponding increase in DAU, and then they adopted a similar approach for their future games as well. Again, the point I want to make is that just from DAU, you can't derive any of that. You have to be collecting these additional metrics. And if there's one area in your game, like if you only kind of do one thing after this talk, there's one area of your game that you need to instrument. It's at that level end scenario. Like anytime a person gets to level end, and your game is going to have some kind of level end, it doesn't matter whether it's match 3 or a platformer or any kind of other game, like there's some level end that happens, like there's some end of play. You need to collect as much data as you can about the player's state at that time. Like you need to collect what level they are, how many times they tried, how many points they have left, what session this is, as much data, and I'll give you some more examples as well, but as much data as you can in that level end scenario. And that at least is going to give you a lot of visibility into seeing player progression through your game. So if you only do one thing, at least do that. Maybe you have that instrumented already, but that's low-hanging fruit that anytime you get a player to that end state, instrument it, and then that enables you to make these fundamental changes to your game. So a little bit of terminology before we dive into some of the deeper tech details. So there's, in all of analytics, this isn't AWS specific, but there's a few pieces of terminology. So an event is just something that happens at a given point in time. Sure, it seems obvious, but the event is actually something that happens, right? Login, end of level, et cetera. And then a metric is what you're actually going to measure. Okay, it's end of level, and I'm measuring the player's hit points. I'm measuring how many times he tried this. I'm measuring what weapon he was using. And the point I want to make here is just keep it simple. Don't overcomplicate the actual data point. Just keep it to a simple kind of one-dimensional data. You can have multiple of these. You can record multiple different attributes, like what level the person was at from a player progression, what item, et cetera. But the more you can break it down and kind of use enum type data and just simple integers, say, okay, he was this level, he had 10 hit points left. Then it makes it much easier when you get to subsequent analysis to be able to do really simple math, sums and averages and stuff like that. So think a little bit ahead. Just try to keep your data as simple as possible, and that's just going to make it easier for you in the long run. And then finally, always include context about the player. It doesn't matter what it is. It doesn't necessarily matter if it's actually a player action. It could just be something that happens in the game. But if you're instrumenting it, always include the player data, because then later you can go on and see whether or not there's any side effects from that event. So for a player event, that's obvious that you would want to record that data. Like, I just completed the level. Here's all my player data. But even if you have a server pushed event, like maybe a notification or maybe a new DLC, record that player data along with it too, assuming it makes sense. Record that player data along with it too, because then you can always go back and correlate it and be able to see maybe unexpected side effects, like, hey, we pushed out this notification, and all of a sudden 10% of our users never came back. And if you're able to actually instrument that on a player basis, then you can track those unexpected side effects throughout your game too. So if you don't have any analytics right now, you're just getting started, common approach is to start with an off-the-shelf analytics tool. And it's a good strategy, actually. There's a few advantages to it. We have our own mobile analytics SDK. Easy to integrate, few lines of code. You get some out-of-the-box reports, DAU, MAU, retention, et cetera. Over time, what the more advanced game companies find is that there are limits to the flexibility. Often it's the case that if you're doing some more advanced reporting on one of these platforms, you can only do maybe one or two kind of secondary groupings of analysis. So that combined with overall retention windows, how much data you can keep in it, and then also data ownership tends to lead the more advanced game companies to then look at doing a deeper level of analysis using AWS, and that's what I'm going to cover next. I just want to highlight one thing that Drew actually mentioned in his talk a little while earlier, data ownership. There's some off-the-shelf analytics platforms that actually as part of their terms of service say we reserve the right to remarket your information and redistribute it, et cetera. We never do that at AWS for any of our offerings. Your data is your data. It's completely yours, completely secure. We don't look at it, et cetera. So just something I want to highlight. The intent here is not to spread FUD about any other services, because there's lots of great services out there. But I just want to emphasize that's something philosophically that we don't do with your data. All right, back to our wacky business plan. So any actual analytics system, AWS or otherwise, basically breaks down into these 4 steps. There's ingest, which is the process of just getting data off the device. Store, you have to put that data somewhere other than the device. Then there's the processing step where you actually go through and you churn through that raw data, turn it into something useful, some kind of useful format, and then finally analyze it, where you actually have a human look at it and make decisions and make changes to the game. So from an AWS perspective, here's how some of our services break down. I'm going to get into the technical weeds here. The simplest concept that you can use on us is you can actually just put your data in S3. And that's very popular, and I'm going to show you some examples of that. Now that we've released our mobile analytics SDK, assuming you're on a mobile device, which I'm assuming many of you are, then you can use our mobile analytics SDK. And in fact, that's the way I would recommend in terms of just collecting data. And then from a storage perspective, you can put that into either S3, which is our simple storage service, very cheap, 3 cents per gig per month. You just stick all of your data up there and then analyze it later. Or use a more SQL-based store like DynamoDB or HDFS, which allows you to do a little bit deeper query. Processing, Redshift is the dominant technology right now from game companies. Like since we released Redshift a couple of years ago, it's basically taken over. And the vast majority of game companies are using Redshift. And I'll show that in the next slide. And then finally, for the analysis stage, Redshift is a SQL-compliant database, so any of the widely available off-the-shelf GUI tools that you want to use, like Tableau, Pentaho, et cetera, Jaspersoft, those you can actually use along with Redshift. So what does this look like from an actual architecture diagram? So I'm a big fan of starting simple. That's one of the things that I think is the killer feature of AWS. You don't have to plan your ultimate end-to-end architecture from day one. You can just add pieces to it as your needs grow. So simplest example, you're just collecting events on the device, maybe just writing it to a game, local save data area in just the super simple area. Again, I wouldn't do that necessarily manually these days. I would use our Analytics SDK, but conceptually, you're just saving these events. And then periodically, you're going to stick it in S3. Again, super cheap. It's the best place to just land all of your analytics data because all of our different deeper analytics tools like Redshift, Elastic Mapreduce, et cetera, that I'll highlight, those all have interfaces to pull it out of S3. So S3 is a great place just to land all of your data. Process it into Redshift, which is our SQL-compliant data warehouse as a service. And then you point one of your GUI tools, such as Tableau, to it. So going back to my, if you do one thing, if you're going to just kind of do one architecture, I would do this architecture. It's a great way. It's cheap. You're talking about something like Redshift. If you pre-buy, if you use our reserved instance capability, you can run it for about $100 a month, actually less than that. And then S3, 3 cents per gig per month. So you're talking about a very low-cost solution that gives you basically as much flexibility from a querying perspective as you want. And then profit, right? Done, right? Drop mic, boot. Anyway, a little bit more details on Redshift then, just so you guys understand what's actually going on under the covers. So it's a managed data warehouse service. So what does that mean? So it's similar to some of our other database services like RDS, where what you do is you actually configure the number of nodes, and then that's what you pay for. And then depending on adding or removing nodes, then you pay more or less. It's really straightforward. The overall architecture is you have a leader node, which is actually where your SQL queries go through. And then you have one or more compute nodes that actually do your data munching underneath the covers, excuse me. And if you've actually never taken Redshift for a spin, we have a free tier that gives you 160 gigabytes of storage, I believe, and you can run it for 2 months for free. All the details are on our website, so if you've never had a chance to play around with it, you can do that architecture that I showed you previously, where you stuff all your data in S3, load it into Redshift, run it for a couple months for free, and see how you like it. And this is an example of interfacing Tableau with Redshift. As I mentioned, Tableau is one of the visualizations tools you can use with Redshift. It's the predominant one the game companies are using. It's easy to set up. Tableau has great support for Redshift. So once you get these two pieces put together, then you have this nice graphical GUI tool that you can point to your data. You can drag and drop, do stuff like Cohort Analysis, which I'll highlight some of that. But it's a really easy way to get all of your data connected. And the thing I want to emphasize here again, the difference between the Tableau and Redshift option and our mobile analytics SDK. So kind of comparing and contrasting those two. So with our mobile analytics offering, you're going to get a ton of stuff off the shelf. You're going to get a lot of pre-baked reports. It's great. I definitely highly recommend using it if you're not using it already. 100 million events a month for free. And then at some point, you're going to want to do some type of report that's probably not supported in the GUI. And that's why we've built into the actual Analytics SDK the ability to export data to S3, which I'll show you in a bit. Once that data then gets over to S3 and Redshift, then you can do that deeper level of analysis. And this is where companies, and a lot of these companies have talked publicly about it. I mentioned Gree, but also Supercell talked a bit about last year at one of our summits about the analytics they're doing with AWS. The big game companies that are really drilling into analytics, they're using Redshift along with a visualization tool like Tableau because they're able to get that flexibility of their queries and group multiple different sources of data together. So some tech details on the plumbing. Pretty straightforward. You create an S3 bucket. If you've never done that, you can do that through the console. You just name it whatever you want. My analytics bucket. You set up a security token. Upload data from your user devices, again, either manually like I showed you, or you can set up the Analytics SDK, and I'll get to that in a minute. You have some kind of regularly set up copy into Redshift, and we actually have details on that. Set up Tableau, and then you go to the beach. One of my, I put that in there because back when I was at Sony making games before coming to AWS, one of my fellow developers would always, he had a great presentation he gave where he talked about the old model of the $60 box product, and I was in online games, hence my exposure to AWS. But he would always talk about the old model of the box product. You would get done with this actual game, and you would ship the game, and then everybody would go on vacation, and everybody would go to the beach. But the world is different now, as we all know. The shipping of the game is only stage one. And that all these other services is you not only have to keep running, but you have to monitor your users and keep tweaking your game for months, if not years on end. So how do you actually get your data into Redshift? Again, straightforward. Once you've got your S3 bucket set up, you're dumping all your data in there, just kind of fire hosing all that stuff in there. And then one line here, you say, OK, copy the events from this S3 bucket into this table, and here are my credentials. And there's a link, and you can either screenshot this, or these slides will be up on SlideShare. There's a link there that walks you through how to actually do this procedurally. And I also have a slide that kind of, oops, what happened? It flashed. Oh, maybe it's not going to go out. OK, apparently it's going to auto-disappear. Anyway, theoretically, if you go to that tiny URL, it's actually a full presentation from reInvent last year that walks you through setting up data pipeline. And what data pipeline is that's our service for actually connecting different processes together in AWS. So you can use data pipeline to say, OK, I want to take from this S3 bucket, I want to ingest all my data into Redshift at X interval, create that data pipeline job, and then run that every night or every 4 hours, et cetera. So once you have that infrastructure set up, the cool thing about it is you can just start adding more and more data to it. First thing, if you're having an online game, you're going to have some kind of game servers, whether or not they be web servers, multiplayer game servers, et cetera. And you can just collect that data straight off of those game servers as well and just dump it in the same S3 bucket. Using the same process you already set up then, you can just keep processing that into Redshift. As you add more and more data, you're just loading it in. And again, any of the external analytics SDKs, whether or not you're using ours or a third-party solution, you can use their APIs and export that data to S3 and just build it into that same workflow. So the idea here is just use S3 as your big dumping ground. Put all of your data there from all of your servers, et cetera. Technically, I think the term is data lake. It sounds much more snazzy than dumping ground. But whatever you want to call it, like just put all of your data in there. And then the key part there is if you don't collect it, you can't analyze it later. Your game server logs are going to roll over. Your device, a person is going to stop playing your game, and they're never going to come back. So just err on the side of collecting as much data as you can. Follow those structural kind of guidelines I gave you. Tag things, create a certain structure with attributes and metrics. Keep it simple. Once you put that thought into it, just collect as much of data as you can and just put it in S3 and worry about it later. It's cheap. S3 is super cheap. You're talking about you can store terabytes of data for a few $dozen a month. So just put as much data in there as you can, and then worry about how to process it later. And from a game server perspective, then, here's a simple snippet. And again, you can get this actually straight off that link as well. It's a half dozen lines of code that you can actually just copy-paste into your servers. And this will take your Apache web logs automatically using the Linux log rotate daemon and just shuttle them up to S3 on a periodic basis. There's a lot of this plumbing that's really easy to just, a couple lines here, a couple lines there, shuttle everything into S3, and then you can load it all into Redshift and do your analysis from it. So as you're doing this then, you're probably going to hit one minor hiccup here, which is how do you deal with different data formats? Right? You've got your Apache logs versus maybe CDN logs, the stuff that's coming off the device. And probably one of the most common ways that we see game developers dealing with it is using our Elastic Mapreduce service. What that is it's a managed Hadoop offering. And in a nutshell, you can just spin up a cluster of EC2 instances, upload a little bit of code to them, maybe Java or Python code, whatever you prefer, that just goes through and correlates, maybe cleans up some of that data, gets it in a kind of common format, and then dumps it back out to a clean S3 bucket, and then you just load that bucket to Redshift. In terms of putting all the pieces together, if you land on something like this, you're going to have a pretty robust set of services that you're going to be able to leverage for analytics. This is going to give you a lot of power at this point. You're talking about collecting data from all of these different sources, cleaning it up via EMR. Relative cost-wise is going to be pretty affordable because EMR, for example, Elastic Mapreduce, you spin that up, maybe it runs for an hour, cleans your data up, spins back down, you stop paying for it. So there's a lot of pieces here that as you put them together, there's a lot of, relatively affordable, like kind of small little pieces here, and you can run this whole thing for, $100 or so a month, and then you're just going to end up, as your data needs grow, that grows, and then if they shrink back down, you pay less. I want to highlight a few other things, and I'm going to shift and talk a little bit about the analytics, the mobile analytics SDK, and then wind up by talking about GRE. Elastic Mapreduce can be used for more than just data cleanup. It's actually a fully featured analytics tool in its own right. It's Hadoop-based. If you're not familiar with Hadoop, it uses, it's a Mapreduce, open source Mapreduce implementation. Our Mapreduce product also includes support for alternate engines like Spark, which is an in-memory version that's gaining popularity. And when you're comparing and contrasting these two, the dominant one being used right now is Redshift in terms of, hey, I want to dig into my data, do the kinds of analysis that I've been talking about. Redshift is definitely the 800-pound gorilla, so I would focus your efforts there. But just be aware, again, some of the more advanced game companies, when they try to do ad hoc analysis that doesn't necessarily fit into a SQL, because Redshift is all SQL. Some stuff does and doesn't fit into SQL very easily. Again, maybe really unstructured data, or maybe you have social data that's coming off Twitter and you want to correlate that. It's not always easy to figure out how to do a relational format of that. That's where using Elastic Mapreduce as more than just a cleanup step can give you some advantages. And when I get to the GRE architecture diagrams, I'll actually show you a little bit more example of how they integrate both of them as part of their workflow. So last thing I want to mention, Drew mentioned in his talk earlier about actually running a mobile game backend. And if your game servers are using DynamoDB, which we highly recommend as opposed to using something like MySQL, DynamoDB is a great fit for game servers. We've seen a lot of games have a lot of success moving from MySQL to Dynamo, getting better scalability, lower cost. So assuming you're using DynamoDB for your game data, you actually have two different options. You can directly export DynamoDB to Redshift. You can also export DynamoDB to S3 and then continue in that same workflow. So the choice there is just, do you want to keep using S3 as your central dumping ground? I'm sorry, data lake, snazzy, as your dumping ground, or do you want to just shuttle your data on an incremental form to Redshift? It's really pros and cons to each one. It just depends on how you're building out your overall flow. So you have that flexibility. All right, so I want to switch and talk about our Analytics SDK. So Drew already covered a bit of this earlier in his session. So I won't get into a lot of details, but I do want to highlight how you can use it actually now as your primary collection method for actually getting the data off of the device and getting it into that analytics backend. So our Analytics SDK gives you a lot of off-the-shelf reports, as I mentioned, DAU, active users, LTV, very common reports. They're great reports to have. If you don't have some analytics offering right now, whether or not it be ours or another third-party too, please integrate one like today, like maybe do that this evening. Absolutely, at the very least, you need to have access, DAU, MAU, retention. You need to just get that pulse on your game. But that's not necessarily enough to make changes to your game, as I mentioned, but you absolutely need that pulse at least to see, okay, are people playing? is my trend overall up, overall down, et cetera. So once you have the Analytics SDK integrated, again, it's just a few lines of code, as we talked about earlier. You get these nice reports. It's a nice graphical display. And you can see, OK, here's my day 1 retention in the lower right-hand corner, for example, active users, et cetera. Common goalposts that you want to use here is 1 day, 7 day, 30 day. Have you all heard of 40, 20, 10 as your targets? So what people say in terms of making a successful game is that you really want your day 1 retention to be 40%, your day 7 to be 20%, and your 30-day retention to be 10%. And if you're somewhere in those ballparks, then you're on a good track to having a successful game. So this will give you the visibility into that right away. You're not necessarily going to be able to make those decisions in terms of what to change about your game if you're not hitting those numbers. That's where you need to collect those additional metrics I was mentioning. But at the very least, this will tell you, hey, am I in the ballpark? Am I trending in the right direction? And then the nice thing, you actually get a pretty nice retention funnel that's broken down by those different quartiles. You got day 1, day 3, day 7 here, for example. Custom events, Drew mentioned this earlier again, but you can track any number of custom events. So back at the start when I was mentioning, OK, here are the type of things that you actually want to track, for example, using our level end as one example. So at the end of a level, I want to track, OK, user was at, this was their personal level, this is the item they were using, this is the number of hit points. You can actually associate all of those with that level end event. And then that gives you actually 2 things. First of all, when it goes into the analytics dashboard through our mobile analytics, you'll actually be able to graph that directly in the console. And then this is what it actually looks like from just a code perspective. This is the Android example. There's an iOS example as well. Straightforward, right? You make one call. You say, OK, here's the attributes. Here's the different metrics. Save it. It goes through the analytics service. And the second thing that's cool about this, if you do this, is that it appears in that same data stream then that you can export to S3 and process into Redshift. So once you get that data, the point being, once you get that data in through mobile analytics, you're using that as your basic pipeline to collect all that data. You get some dashboard functionality out of it, and then you can take it to Redshift, do that secondary level of analysis. As mentioned, 100 million events per month for free, which is a lot of events. OK, so go over now auto export. This is the feature I've been mentioning, but just to recap, you can actually just go in through the console and say, OK, mobile analytics, I want to configure this S3 bucket. I want to configure this is my ID for my mobile analytics that I've set up. And you configure this S3 bucket, and then you can set it to actually export to S3 on a regular basis. It's basically 1 hour intervals right now, so your data is going to be less than or equal to 1 hour old. But one of the occupational hazards of working at AWS is that as of this morning, that is kind of irrelevant, because now what we offer is the ability to just auto-export directly to Redshift. Yay, yes. So fresh, hot off the presses, right? You saw it here first. The cool thing about this, obviously, is a lot of that stuff I mentioned earlier about setting up a pipeline and setting up the export from S3 to Redshift. You actually don't have to worry about that. If you're using our mobile analytics SDK, you'll just be able to connect the 2 end to end. So what does that look like? When you go into the console under mobile analytics, you just select it from the menu. You'll go through a couple dialogues where you set up your credentials on the left side. That's what this shows, and set up ports, passwords, et cetera. You get a little progress bar, and then when it's all done, this is what's running in the background. You don't necessarily have to worry about it, but this is actually what's being set up in the background. There's a node that's pulling data out of mobile analytics and then loading it into Redshift at a regular basis. So theoretically, probably I could have just saved us all a lot of time and just jumped straight to this slide, but I had an hour to fill, and I had already put all those other slides together. So again, one of the occupational hazards. But I will mention, in all seriousness, if you're not using the mobile analytics SDK, staging your data to S3 still makes a lot of sense. For example, maybe you're doing a PC game, maybe you're doing a console game, maybe you're using a third-party library. For all of those, you can still follow that same workflow. Still very straightforward to set up. You just dump your data into S3, set up that data pipeline to load it into Redshift in a regular manner, and then you can do all of your visualization in Redshift. Cool. So I wanted to give you a few examples of the kind of stuff you can actually do in Redshift to kind of drive it home. So we saw that dashboard of what we would get out of the box, for example. What if we wanted to drill in and say, OK, we want to see the number of the 30-day retention actually broken down by devices? So this is a SQL query, and you can actually find this in our documentation that shows you. And what this does is it takes the same analytics data that you have available in the mobile analytics SDK and the mobile analytics dashboard, but then once you've loaded into Redshift, you can actually do a more complex query than you might be able to do via the dashboard. And the advantage to building up these SQL query snippets over time is that then you can copy paste and do a lot of more advanced analysis. Let's say you want to take that and you want to start segmenting your users by language and say, okay, I want to see whether or not people in the US, people in Germany, et cetera, are having different retention values. And I put this example up here just to illustrate a point, which is that even stuff like DAU and MAU is actually pretty straightforward when you do it in SQL. I literally just grabbed this off Stack Overflow. There was probably a half dozen examples that took me about 5 minutes to search, but this one would work with Redshift, for example. And all it does is it just partitions the date, partitions your time-stamped data either by day or by month, and aggregates that, and that gives you your DAU and MAU. So the point being is once you get into Redshift and once you get used to doing these SQL snippets, you can build up a pretty good library of them. And this is the methodology that these more advanced game companies are using, the Supercells of the world, is they're building up these libraries of more advanced SQL queries, and they're running these on a regular basis. And a couple more just to gloss over here. This is stuff that's more difficult to do in a actual visual diagram. So we want to measure repeated plays, for example. And this is a very naive increment. The first time, maybe I would go and I would group it all by month. What that would give me then is for a given user, though, it's you see a lot of data here that doesn't make a lot of sense. Because what I've done here in that previous query is I've grouped the data basically by date, by user, and so it shows what a given user is doing, but all I really get on an aggregate query is noise. So what I want to do is cohort analysis, which if you're not familiar with, it just means grouping people together. There's a lot of fancy terms in data analytics that are just terms for other things. But cohorts is basically you just create a group of like people. And they might be similar people based on the date they joined, which is very common. That's typically the way you measure retention is the first day they play. You create a cohort based on that. And when you look at retention metrics that are in dashboards, typically that's what they're doing underneath the covers, right? They're just creating a cohort based on the first time they played, and then they're mapping out the number of sessions after that and turn that into a graphical display. But you might also create a cohort by language. You might create a cohort based on if you have a couple different games, maybe you want to correlate people together. So when we create a cohort for this data, again, it enables us to do relative metrics compared to a group, and then we actually do the analysis by that cohort rather than on an individual basis. And Redshift has a lot of advantages here because that just turns into a pretty straightforward SQL query. So if we go back to our query then, we just change the way that we're actually grouping people together, and what that gives us is this number of sessions kind of, in this case it's not retention, but this is basically showing the number of sessions and the number of times they're playing based on their join. And again, this is hypothetical data, but it's very similar to what you would expect to see in your game. Maybe a person plays, they play a few times, they fall off, and then after a few weeks they stop playing. So wrapping this up, and then I want to talk about a few real-world use cases and end on greed, just to give you an idea of what one of these full-featured kind of end-to-end workflows look like. So Forza Football actually did this with they talked about this at reInvent, and this is actually coming out of our mobile analytics SDK. They did a really interesting set of cohort analysis where they grouped people together based on the number of mobile push notifications that they were sending. Because they were sending mobile push notifications, and they couldn't figure out why people were dropping off. And what they found is that they were just annoying users. Is that they found that if they sent them more than 10 notifications, then people were like, this is way too much, I'm uninstalling the app. So some of you, maybe you would say, okay, well, that seems reasonable. I would kind of guess at that if somebody sends me too many push notifications, that I would uninstall the app. But the take home here is like, this is actual data now. You can actually make a real decision based on real world data and say, okay, we're not just guessing, we're not using intuition, we're not saying, oh, like 5 seems like a good number. You actually have measured data from your users to see, okay, this is your sweet spot, send 5 to 9 notifications and you're retaining about 2x better. Send more than that, less than that, you're not getting your best bang for buck. One other interesting thing here that's not shown that might be a follow-up question you might be thinking is, okay, number of push notifications over one amount of time. Did you send all 10 of these on one day? Did you send all 10 of these like over 6 months? So that, again, is another example where you might want to drill into it more. So this might be, this is your lifetime, but you might want to say, okay, let's further dig into it and say, okay, if a person receives more than X notifications in a couple days, is that going to make them more or less likely also to uninstall the app? So it's a great illustration of the kind of things that you can do when you combine mobile analytics, you export it. This is actually a graph with Tableau plus Redshift. And if you're interested in this in more detail, if you go and look at our actual reInvent sessions from last year, look for the Forza one. It's all, there's a lot of more details. They did a bunch of other stuff with our mobile analytics SDK. All right, to wrap up, we've got about 15 minutes left. I want to talk a little bit about GREE, who shared their real-time analytics architecture with us this past reInvent. So it's a great example of a real-world use case using AWS for analytics. And the cool thing about this, I think, is it follows really all of our best practices in terms of using our different services together. And it's also very indicative of what we see across the industry. So it's great from a number of angles. Just to give you some statistics, they're, again, similar to what I was mentioning. They're pulling data from a lot of different sources, from mobile devices, ad networks, external data as well. In terms of individual events, their given events are only about a K, but they're sending 500 million of these a day, which gives you about 500 gigs of data and growing. And they're sending everything in JSON. And the nice thing about JSON is then you have a schema actually embedded in the JSON. I'll show you the example of what they're actually sending. The way their games are architected is each different game that they actually host has their own database. And then in a given game, each of those different games correlates then to a set of event tables. So that means that for a given game, it has about 40 to 50 of these tables in that game. So when you multiply that out times the number of games, they've got about 1,000 tables in their Redshift data warehouse. The take-home point here I want to highlight is that they didn't start out with 1,000 tables. They didn't have to pre-plan for 1,000 tables. They started out with 10, 20, 100, whatever, and they just kept growing the size of their Redshift cluster as they needed more. And in terms of their data format, it's similar concepts to what I was mentioning earlier, right? They have a set of web services. They have a client-side SDK that they wrote. The reason why they wrote it is both to get their cross-platform support and also because it predates a lot of the other SDKs that are available now. But they're sending everything in JSON, which is a great practice because then you can just look at it. You can inspect the data. Redshift reads JSON. Mapreduce products read JSON. It's just a great universal format. And some of the things I highlighted here in colors is just to show you they essentially made their data schema aware. So they said, OK, here's the type of event. Here's the table it's coming from. And then as I mentioned earlier in terms of best practice, they're stamping everything with the actual session ID and then the timestamp as well. So it allows them to analyze it both not only from aggregate perspective, but actually do time series analysis, which is really important. And from an architecture perspective, GREE initially started out with very much the same S3-based structure that I was mentioning earlier. And what they found over time is they wanted more real-time feedback from their game. So what they've done is they migrated to Kinesis, which is a newer service that we launched about a year ago. And what Kinesis is it's our managed data transport. It's just JSON over HTTP. And essentially, you just stick data in from multiple different sources. Then you can define multiple different outputs on the back end. Then you have one or more consumers that are just reading messages off Kinesis and making decisions based off it. So what they do, this was kind of their first version of this Kinesis-based infrastructure, is they split the stream, and they put half of it into S3, going to Redshift, and then the other half of it, S3, going to Mapreduce. And this is a good illustration of what I was mentioning earlier when I said, OK, the two can complement each other really well. So they're using Redshift for all of their weekly and nightly reports. Their stuff that they've kind of solidified and decided, OK, this is a report we want to run on a nightly basis. Give producers access to this. Producers can just go into Tableau, pull down their own dashboards, and actually see how all this data fits together. And then for the newer, more ad hoc analysis, where they're not, in a way, not sure what they're looking for yet, they're doing that in Mapreduce. So that combination is quite possible. You can also do a lot of that, digging in Redshift too, using SQL. But it ends up being a flow that we see pretty frequently for the more unstructured stuff where you're pulling in raw data, iterating that on Mapreduce, turning that into a more structured report, and then putting that back into Redshift, and kind of this cycle of doing your data science, your data research in Mapreduce, and then ending up in Redshift when you're done with it. So at the first diagram I showed you, where you're dumping all of your data into Redshift, or dumping all your data into S3 and then loading it into Redshift, what I want to point out here is that you can still get to this end state by just starting with that state I mentioned, right? Like the S3 to Redshift here, that can remain exactly intact. So the point is you don't have to pre-design this whole thing. You could just start out putting all your data in S3, loading it into Redshift, and then over time, if you say, you know what, we want more real-time access to our data, you can put a Kinesis stream in front of that, write a little bit of code, and then you can split the stream, send that data still to your batch data warehouse, and then have a more real-time stream going to some other type of processing. And as I mentioned, writing into a Kinesis stream is just JSON over HTTP. You just set up a stream, basically. You say, here's my input, and then on the other side, you can have one or more consumers that are actually just reading events. Kinesis guarantees ordering. It's very low latency. Actually, as of today, we just, again, announced that latency is now 0 for reading off of a Kinesis stream. So you can actually instantly get, we have instant consistency for a given stream. And that's documented on our blog as well. Again, I didn't have time to put that in the slides because I just found out about that midday, but at least I can mention it to you verbally. So wrapping up here, I want to just end with what Gree's actual final analytics solution looks like. And this is actually what they're running in production now for all of their games. If you're interested in this, I would highly recommend looking at Gree's presentation from reInvent last year. They actually did a great job. They talked about all the mistakes they'd made over the years, all the lessons learned, all the skin and knees, et cetera. So it's a great talk. Where they ended up is they just stick all their data. They are just sending it in real time via Kinesis. They have multiple different producers. They have mobile clients that are producing data. They have game servers, et cetera. They're just sending it all through Kinesis. And then they're forking that into a couple different things. First of all, they're sending it to Spark, which is the in-memory version of Hadoop I was mentioning. You can run that on top of EMR as well. It's just basically a different engine for EMR, and we have that in our documentation. It's very popular for doing low latency real-time analysis. What that gives them is that dashboard of like, hey, what's happening in the game right now? Like if I actually go and I look, like what are people doing right this second? So it's great to give you visibility into what's happening. You can't necessarily make game design decisions based off that, but it's a great, augmenting your monitoring is being able to say, okay, hey, what's happening in the game? Is there either anything to worry about or is there anything interesting, maybe an event or something, and maybe we can start, tweeting about it or something, drive more interest in it. Then they have another consumer that's putting it into Dynamo and building another set of dashboards, and then finally joining that together with a third consumer, which is actually putting it into that part that I already mentioned with putting their longer-term reports in Redshift and putting their more ad hoc analysis into EMR. And again, Gree talks about this in depth. It's a great talk. They talk a lot about some of the nuts and bolts that they found through using Kinesis. So it's a great talk to check out if you have the time. So I'm going to end here on a very cheap, easy way to get votes for a good session rating is I'm going to talk about saving you money. I'm going to talk a little bit about spot instances. So if you are using Elastic Mapreduce or other EC2 services, actually, we have a great option for consuming our EC2 instances called Spot. If you've used AWS before, you're no doubt familiar with the idea that you spin up an EC2 instance, you pay for what you use, it's running for an hour or 2 hours, you pay for that, you spin it back down, you stop paying. Similarly, you can actually use a reserved instance where you prepay an upfront fee and the cost comes way down. We've got a third option, actually, that's great for analytics workloads, which is called spot instances. And with spot instances, what you do is you essentially bid on it like a stock market, and you say, okay, I want to pay 3 cents an hour or 10 cents an hour, or whatever I want to pay for this instance. And what we'll do then is we will spin that instance up for you only once that price is reached. And then as long as the price is below your threshold, you'll get that instance, and then when the price jumps back up, or when you end when your actual job is done, whichever comes first, then you lose that instance and you stop paying. So these are actual real-world examples. These aren't made up. This is actual data where you could save 80+% based on the spot market. And what we'll actually do is you can go into the console and see a price history. So when you're trying to figure out, hey, what should I actually bid on a spot instance, you can actually go into our console and you'll actually see, hey, here's the 30-day or whatever history of these instances. And you can drill down by instance type, say, okay, I only want like a C3 instance, which has our high CPU capabilities. And then you can say, okay, here's a good amount to bid on it. And then you can launch instances accordingly. What does that look like? So this is an example using auto-scaling. So auto-scaling is our technology for just spinning up and spinning down groups of servers. So you could use an auto-scaling group, for example, to host your Kinesis consumers. So if you think back to that diagram, I showed Kinesis, and then you have this consumer that's actually reading off that Kinesis stream. Well, that consumer is going to be an EC2 instance somewhere. You could spin that EC2 instance up via a spot group. And when you spin it up, then the way you do that is you just specify the spot price right there. You say, OK, I don't want to pay more than 5 cents. And the advantage to doing it that way, again, is if it's for a workflow where you don't need it to happen like right now, but you need it to just happen maybe in the next hour or two. Think of an overnight processing. You're loading all of this data into S3, and overnight you want to do some kind of data cleanup, and you don't really care if it happens at 11 p.m. or if it happens at 2 a.m. It doesn't matter, but when you wake up the next day, you want the data to be processed. You can spin up a scaling group like this, and it'll actually spin up that instance at some point. Your data will get done, and then results will be waiting for you when you wake up. So that was auto-scaling. Here's the same thing using our Elastic Mapreduce, the Hadoop version. Again, it's just the same concept. If you see at the bottom, it's just an extra parameter. You just say, here's what I want to bid for a given task node. I don't want to pay more than that. OK, I've just got about 2 minutes left, so bringing it all back to the top. This was that diagram that I showed that just said, hey, if you have one diagram you want to implement, this is the one to do it. I just wanted to bring it back and just end on this. You kind of cement this in your mind. This is what you should be shooting for when you're talking about, hey, I want to do that more in-depth analysis. Fine, I'm going to use maybe the AWS Mobile Analytics Sdk, or I'm going to use a third-party analytics solution just to put it in my game and get those DAU, MAU, et cetera. But in terms of getting to that deeper level of analysis, think of it this way, right? You're going to be getting the data, pulling it into, say, S3 as your landing pad, loading that into Redshift, and then doing that analysis via a GUI tool like Tableau. And what that enables you to do over time then is build out something like this. As your game grows, you have multiple titles, et cetera. Then you can actually just keep adding pieces to it. The cool thing about AWS, what got me geeked out about it and started with it in the first place, is you don't have to design this all in the start, right? You don't have to go and buy hardware. You don't have to say, OK, well, I need to think about what I need 3 years from now and start paying depreciation on it. When you get to this point, you add these services on, and then you can keep adding more and more functionality analytics-wise. So that wraps it up for me. And GDC 6 is the bit.ly link here. Please do leave feedback, good, bad, or otherwise. And thanks for coming.